Geometric series and sequences. Geometric sequence. A geometric series is the sum of the terms in a geometric sequence, where each term is multiplied by a common ratio r. To calculate the nth term of geometric sequence, use the formula a(n) equal to a1 multiplied by r power n minus 1, where r is the common ratio given by the formula r equals 2 a2 over a1, where a2 represents the second term of the series and a1 represents the first term of the series. Let's see an example. Consider series of numbers 2, 6, 18, 54, 162, and so on. To identify if the given series is in geometric sequence or not, we have to find the common ratio, r, which represents the ratio of consecutive terms. Let's consider the series of numbers as a1, a2, a3, a4, a5 terms, and so on. Now let's calculate the common ratio of first two terms of series, that is, a2 over a1 equals to 6 over 2, that equals to 3. Now let's calculate the common ratio of second and third terms of series, that is, a3 over a2 equals to 18 over 6 equals to 3. Now let's calculate the common ratio of third and fourth terms of series, that will be a4 over a3 equals to 54 over 18 equals to 3. You can observe that each ratio is 3, so the sequence is a geometric sequence. Finite geometric series. The sum Sn of the first n terms of a geometric series can be calculated using the formula Sn equals to a1 multiplied by 1 minus r power n over 1 minus r, where a1 is the first term of the series, r is the common ratio, n is the number of terms to sum. Example. Find the sum of first four terms of the series. Given a equals to 2, r equals to 3, n equals to 4. Solution. The sum of first n terms is given by Sn equals to a multiplied by 1 minus r power n over 1 minus r. Now, substitute the values. That is S4 equals 2 multiplied by 1 minus 3 power 4 over 1 minus 3 equals to 2 multiplied by 1 minus 3 power 4 over minus 2. That equals 2. 2 multiplied by 1 minus 81 over minus 2 equals 2. 2 multiplied by minus 80 over minus 2. Simplify. 2 in the numerator with 2 in the denominator. Also simplify. Minus in the numerator with minus in the denominator, that equals to 80. Infinite geometric series. Sum of an infinite geometric series is given by S infinity equals to a over 1 minus r. Example of infinite geometric series. Given a equals 5, r equals 0.8. Sum is given by S infinity equals to a over 1 minus r. Substitute the values. Sum is S infinity equals to 5 over 1 minus 0.8. That equals to 5 over 0.2. That equals to 25. Thanks for watching.